students, myself Dr. Bharti Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Srigonda, Ahmednagar. We have started our chapter related to solid state physics, and we have started the chapter number 4, magnetism. And during our last lecture we have covered few of the points related to superconducting phenomena. And in today's lecture we are going to see what is Meissner effect. In the year 1933, Meissner and Rosenfeld have invented one phenomena related to superconducting materials, and this is very much important phenomena related to superconducting nature of the materials, and it is called as Meissner effect. In normal state, if we try to penetrate the magnetic field, or when we apply external magnetic field to the material, then in normal state the magnetic line of flux will easily penetrate through the material. But as we decrease the temperature of the material to a temperature known as critical temperature or the transition temperature, then the magnetic line of flux will not penetrate through the material, but they will start to expel from the interior of the superconducting material, and this property is known as Meissner effect. Suppose this is a superconducting ring, and or suppose I have taken one superconductor which is in normal state. How to denote normal state? At normal state, temperature of the superconductor is less than its is greater than its critical temperature, that is temperature at which this material shows superconductivity or its resistance becomes zero, and H, that is applied magnetic field, should be greater than Hc. This state condition denotes the normal state of the superconducting material. So, what Meissner and Rosenfeld have observed, that at normal state, suppose we applied the external magnetic field H to this superconducting material, then magnetic line of flux will penetrate through this material. Therefore, in the interior, this material will get magnetized, and hence the magnetic induction inside this material will not be equal to zero. This is called as normal state of the superconducting material. But they have observed that if we applied external magnetic field and reduce the temperature of the superconducting material to the temperature below critical temperature or equal and below critical temperature, and when H is less than Hc, then what they have observed, this is called as superconducting state. When material reaches to superconducting state, that is when its temperature is equal to or less than critical temperature, then they have observed that this magnetic line of flux should pass through the superconducting material. But they have observed that the magnetic line of flux will not pass through the material, but they will expel from the interior of the material. Magnetic line of flux will not pass through the material, but they are expelling from the interior of the material. Hence, in the interior of the material, at T less than or equal to Tc, B becomes 0. And this is the observation of Meissner and Rosenfeld related to superconducting nature of the material, and this effect of expelling magnetic field from the interior of the superconducting material at a temperature less than Tc is called as Meissner effect. What is Meissner effect? Expulsion of magnetic field from the interior of the superconducting material at a temperature less than or equal to Tc, or transition temperature or critical temperature, is called as Meissner effect. And Meissner experimentally observed that this effect is reversible. This effect is reversible means what? So, what is Meissner effect? Meissner effect is expulsion of magnetic field from the interior of the superconducting material at a temperature less than Tc is called as Meissner effect. It means that the temperature will be in normal state, the material will be in normal state for all the temperatures which are greater than Tc, and the material will be in superconducting form, that is its resistance becomes zero for all the temperatures which are equals or less than T. If Tc, for the temperature less than Tc, the material will be in superconducting form, and as we know that this effect is reversible. It means that if we increase the temperature from Tc to T, then what will happen? The superconducting nature of the material will get destroyed, and again it will get converted into its normal state. And hence this effect, Meissner effect, is reversible. Then we know that in the interior of the material, superconducting material, for all the values of T which are less than Tc, the B value is 0. Therefore, we know that magnetic induction is given by formula B is equal to mu 0, that is permeability of the free space, into applied magnetic field plus magnetization produced. This is the formula for magnetic induction B, and we know that as per the Meissner effect, in the interior of the superconductors there will not be any magnetic induction, that is B is equal to 0 at T less than Tc. So substituting value of B here, we have obtained 0 is equal to mu 0 into H plus M, that is H plus M is equal to 0, and we know that M is equal to minus of H, and hence M upon H comes out as minus 1. But we know that the M upon H is the value of the susceptibility. It's the value of susceptibility of the superconducting materials, and the susceptibility value is found to be minus 1 in case of superconducting materials. It means that superconductors are having diamagnetic nature because their susceptibility value is negative. As susceptibility value reversibility value is negative, superconductors have diamagnetic nature. It means that if we bring a magnet or bar magnet close to the superconducting material, then it will expel it or it will repel the external magnetic field or the external magnet which comes close to it, and hence this property of the superconductors is used to build or fabricate frictionless bearings. They are used in this property is used to fabricate frictionless bearings. Also, this property of Meissner effect is used to generate the magnetically leviated trains called as maglev. They are used to fabricate the trains which are having very high speed, and they are called as maglev. In case of maglev, the tracks are made up of magnetic materials and their wheels are made up of superconductors. And we know that superconductors repel the magnet, and hence these trains or the rails mm, wheels hovers over the magnetic material, and hence there is frictionless transmission or transportation of this train, and hence they will obtain the high speed of the order of 450 or more kilometers per hour. High speed trains are generated with the help of this phenomena of Meissner effect in case of superconductors. So let's revise today's point. Today we have seen most of the important point related to the phenomena of superconductivity and related to superconductors. It is called as Meissner effect. It was invented in 1933 by Meissner and Rosenfeld, and they have shown that if we take a normal if we take a superconductor and when its temperature is below critical temperature, then the magnetic, and if we apply the external magnetic field to it, then magnetic line of flux will penetrate through the material, and this condition denotes the normal state of the given superconducting material. But when we lowers its temperature, and when the temperature of the given superconductor reaches to a value which is less than Tc, then for this condition, this magnetic line of flux will not penetrate through the given superconducting material and will try to expel from it, and hence this phenomena of expelling the magnetic field from the interior of the superconductors at a low temperature of Tc or below Tc is called as Meissner effect. Meissner effect has various applications, such as it is used in frictionless bearings, it is used to fabricate the high speed trains called as magnetically leviated trains. Then we know that this effect is reversible. As we increase the temperature of the material above Tc value, then again this material comes to normal state. If we lower its temperature below Tc, then again it get converted into superconducting state. Therefore, Meissner effect is reversible. With the help of Meissner effect, one can determine whether the given superconducting material is having diamagnetic nature, paramagnetic nature or ferromagnetic nature. And we know that in the superconductors, in the interior, B is equal to 0. We know that magnetic induction is given by formula mu 0 into bracket H plus M, where mu 0 is the permeability of free space, H is called as applied magnetic field, B is called as magnetic induction, and M is called as magnetization produced. As In superconducting state, B is equal to 0. By substituting this value in this equation, we have obtained the ratio of M upon H as -1. But M upon H is nothing but the suscept, susceptibility of given superconducting material, and this superconducting susceptibility value is found as the negative, and we know that for diamagnetic material susceptibility value is negative, and hence these superconductors are having diamagnetic nature. That is, most of the line of flux will not penetrate through the material, but they will pass through the external field. This is all about Meissner effect. Thank you.